is what has, got us going with all those beautiful projects. So I'm going to share today a little bit of our results. I'll try not to go too academic on you, but I have a couple of graphs because I can't hold it. And so I'm going to be talking about reintegrating sheep into our agricultural landscape. So we're lucky in California. I mean, I don't know if you know, I'm not Californian. I'm French, yes. I've been here for 4 years, and something that struck me upon arrival is how much diversity do we have in our landscape and how little we're using it. The reality is that we have a lot of those very intensified cropping systems and a lot of opportunity to diversify those cropping systems. In my lab, we're working on the opportunities and benefits of intercropping, of growing food crops and some other species in perennial landscapes, and also of reintegrating sheep into our perennial cropping systems. This is the first graph. Bear with me, but I just want to show you that diversification strategies are really critical to provide some ecosystem services. This is a paper that was published last week in Nature, one of the biggest scientific publication journal in the world. So when I'm saying there is a critical mass happening, I'm not kidding, right? And what you're seeing here are the services that a monoculture of row crop produce. It produces crop, and that's about it. This is the services that produce a mixed cultivated forest and range landscape, right? One of them being pest control, but also carbon sequestration. And you can actually see it very well in this picture, what can be the ecosystem services provided both at the field scale and at the landscape scale in terms of reconnecting our different landscape elements. So diversification provides critical services from field to landscape scale, and there is a critical need right now to ecologically intensify some of those most intensified cropping system in the world. And that will, this transition usually happens in 3 steps. First, efficiency gains, and this is what agronomists are talking about. Okay, let's be more efficient at using nitrogen, for instance. The second strategy is to substitute those inputs by using nature. And we're starting to get that. The last step is to really redesign our system. And this is where sheep integration into a cropping system comes in. One of the main barriers right now in our ability to diversify our system is that they are extremely decoupled. You have specialty crops on one side, big animal production on the other side, and large crop production system completely decoupling crop from livestock. What's the problem with that? Well, this is creating a problem for agricultural sustainability. The first one being the underutilization of some of those services animals can provide, and some synergies between operations, and we've seen some very great examples in the video. Water contamination, greenhouse gas emission associated with manure management, it's a big problem. It's a big focus of the policymaker right now, but also a lost opportunity to recycle nutrients and to build up our soils. This is the second graph I'm going to show you. This is where nitrogen comes from globally. This is synthetic nitrogen fertilizer. Look at manure, so underutilized, despite all those animals being available. So we're missing an opportunity, whether it's through fresh manure addition or through compost or through direct reintegration of livestock into landscape, to build up our soils and to reuse and recycle those nutrients. And finally, despite the economies of scales we've seen and we've been very successful collectively in creating, there is an added cost to the food system, but also to our planet. And this is our climate smart goals. We need to adapt and we need to mitigate climate change. And I'm saying this to my students in every single lecture because I want it to be on there. Surprisingly enough, it's not enough on their radar. What are the opportunities? This is a scale of diversification, right? You go from single species pasture or row crop monoculture up to rangeland, right? Rangeland is some of the landscape elements that are the most extensive. There's incentive and regulations. This is our path forward for California in terms of greenhouse gas emission. Okay, we have a very aggressive plan to mitigate greenhouse gases. So that's creating opportunities as well to realize that soil are the biggest carbon sink on Earth. New land use, okay, it hasn't escaped you that in our landscape we have much more perennials. But it's a challenge, but also an opportunity. And then shift in management practices. I work a lot with almond growers and walnut growers to try to get away from this way of harvesting nuts so that we can finally have a cover on the ground and eventually graze it. And then growers want to exit this treadmill of I apply pesticide and so I unbalance my ecosystem and I always need to apply more to get it going. This is what we call the treadmill they're on. So there's an opportunity here. So what has research shown today? In terms of reintegrated sheep into landscape, agricultural landscape worldwide, there's 4 studies. So that's not a lot. And it's mostly in cotton with winter-rye cover crop grazing. What do they find? Well, they find that there is a lot of benefits that are very interconnected. And this capacity of having the livestock in the landscape is the nucleus of that. The integrated system, when you had sheep grazing in a cotton winter-rye system, you reduced irrigation water by 25%. You reduce fertilizer use by 36%, reduce herbicide need, improves various soil health properties, including carbon sequestration, and eventually be more economically competitive and profitable. Can we translate that to California, right? And this is what, no, this is not yet what I wanted to tell you. What we don't know is how climate smart it is. What is when you have sheep in a landscape grazing under perennials, how much nitrous oxide less do you emit? How much carbon do you capture? And what are the co-benefits? Now, sheep can have a very direct effect by providing a carbon and a nitrogen source, recycling those nutrients through their guts, and offsetting inputs, but also an indirect effect through increasing the soil capacity to actually sequester this carbon, because the biochemistry of this carbon is changing. And you all know what grazing is going to do to your biomass reallocation. You have more biomass going in the ground, more root growth, and this is a very important factor for carbon sequestration. So what are the co-benefits? Well, if you increase your organic matter by 1%, you can actually store 25,000 gallons of water. That's one co-benefit. You increase aggregation, decrease dust, and it goes on and on and on. Carbon is the nucleus. Now the question that I get all the time is what are the balance between benefits and trade-offs? And I work with big agricultural systems, so trade-offs are very important to the grower I work with. So we started a small coalition working with Chaos Sheep Outfit, and this is a picture taken by Paige Green showing Chaos grazing in Fetzer-Bonterra organic vineyards last year. According to the California Department of Food and Ag, 49% of vineyards have a cover crop, so planted. The rest of them are going to have bare soil or just leave the resident vegetation grow. So a huge opportunity to graze in vineyards. And we don't have this food safety problem because we're going to drink wine. So we started to look at ecological intensification of those vineyards, working with Community Alliance, with family farmer. Fibershed, again, funded all this research. We work with Robert Sinsky Vineyards, Chaos, Shannon Ridge, Bonterra, and some of my buddies and friends that are interested in better understanding farmers' perspective. We started by surveying some land that was grazed or ungrazed for the last 10 years. So we chose bird sites next to each other that were co-managed But this parcel here had 10 years of sheep grazing, this one did not. And we did this at various places around Napa, Sonoma, and Lake County. They all had, so we tried to have similar co-management, same viticulturist, same soil texture, and same vine history. And we focused on soil, and soil health and soil carbon sequestration. Now, carbon is complicated. There's a lot of different forms of carbon in nature. There is what we call a labile fraction, which is the carbon that turns over very fast. It is assimilated into the microbiomass, it is respired. It is a very, very active carbon pool. And then there's this pool here of recalcitrant carbon, and this is what we really want to build up. This carbon is being sequestered for decades, 2 centuries. And this is how we effectively take this carbon from the atmosphere into our soils. Now, in integrated vineyards, we're increasing this carbon by 17%. That's 12 tons of carbon per hectare. And what you can see here is that this labile fraction is actually not moving. So we're sequestering it in a very stable form in our agroecosystem. So we had no change in this very labile fraction. We see other benefits. You have more organic nitrogen, more phosphorus in the system, and again, this is in vineyards. And a soil that is alive. It is more biologically active. You have more carbon and nitrogen cycling. You have more fungus. And your fungal to bacterial ratio is changing, which is very helpful to sequester carbon. And we have more beneficial microbes. We have twice the number of mycorrhizae, which are some very interesting microbes that help the plant take up nutrients. Some potential trade-offs, it might increase salinity in some cases. Our study on compaction is inconclusive. Compaction, I don't think a bunch of sheep is going to compact more your soil than a bunch of tractors. But we do have to address this issue to try to talk to growers. And then we have more nitrate, and nitrate can be easily leached into our soil. So that is a potential trade-off as well of having sheep grazing in vineyards for more than 10 years. Now we want to know more. And this is the study we're starting. We want to know more about carbon sequestration and how come, about nutrient cycling, about soil structure and biodiversity, because at the end of the day, this is all going to be connected into how much labor you need, how much fertilizer you use, how much water you store, and how much energy you're using to produce your water. And at the end of the day, the economics and income returns that you get on your land. So this is our quest, and I just showed you today this little box, and we're working on all those other boxes. But to do that, we need more holistic data. And we were able to recently leverage funds from Fibershed to get some larger stakeholder money from the California Department of Food and Agriculture with around $300,000 to start the first grazing trial here in California. We're going to be working at the Napa RCD. They have a demonstration vineyard, and we're going to build a research and outreach platform. This vineyard has been managed with till or no-till and different soil cover for the last 23 years. And we're going to overlay sheep grazing on top of it. And we're going to monitor all those things I showed you. Water, energy, labor, pesticide, biodiversity. So we can really start mapping out all the benefits and potential trade-offs. We'll be grazing during dormancy. We've been talking to farmers, why aren't you grazing? They know some of the benefits they can get, such as fire prevention, limiting labor, but there's also some very big barriers to adoption. It's hard to manage. We don't know how to do it well. We're worried about compaction. What about my irrigation drip lines? So we need to address that if we want to really make an impact at a larger scale. Now, I went to New Zealand a few weeks ago, and everyone knows in this crowd how New Zealand treats their sheep. There's 27 million of them, and there's 5 million people. 100% of the viticulturists in New Zealand integrate sheep during winter dormancy. 100%. 13% utilize sheep for leaf plucking, and 7% have sheep grazing all year long, okay? Different trellis system, baby doll, mind you, but it is possible. What are the main benefits? 100% say we don't need to mow anymore, we have better frost protection, and we're marketing it for our wine. We're making an added value to it. Other benefits was just additional feed available in the landscape and some soil benefits, but that was not very high on their radar. This is some of the quotes I took from some farmers there. Sheep are as good as herbicide. I used to go September to February nonstop. I'm not doing this anymore. So yeah, 100% of them are integrating in their vineyard. What is the cost saving? Well, we started to do the calculation. It's an average of $64 per hectare and 1.3 times fewer herbicide application across their vineyard. Now they do perceive some of their challenges, but the benefits greatly outweigh the cost, according to farmers. There were sometimes sheep are going to chew on wires and drip line, yes, but there is some solutions to that, need for fencing, etc. But overall, perceived challenge are way less than the perceived benefits. The last thing I wanted to share with you is a new trial that we're starting as well, and this trial is going to run for 100 years. This is what we call the century experiment, because this is the kind of scale we need to be working at, right? It's going to outlive us. And this is an experiment that was starting 25 years ago at UC Davis, and we're trying 11 different farming systems. And this year, for the first time, we're going to be grazing into those small plots in the fall, some of the cover crop. And we're going to look at soil and system productivity, but also food safety. So this is very exciting new development that will outlive us. So our research model is that we are doing experiments, but we are also surveying farmers and grazers and trying to understand the perception, the barriers to adoption. And then we're also trying to model those systems, because that's the only way we can get at resistance, at resilience. It's kind of in silico in our computer, stressing the system out and see how they bounce back. So this is kind of what we're busy with as well, and of course having all those three components being fully integrated. So I just wanted to leave you with that, and if you have any question, feel free to ask. I again want to thank Fibershed for making this happen. Thank you. Questions? Do we have time for questions? Yeah, one question. Yeah, one question, one, two questions. That was so clear, there's no questions.
What has surprised you the most in the research or in the findings? What were some of the biggest surprises to you?
What surprised me is that we're able to sequester carbon in a recalcitrant form. What I thought is that we're going to build up our soil microbes, we're going to have this very lay-by-4 of carbon being exchanged, and we might not be sequestering this carbon on the long term. And it seems that through grazing, the biochemistry of this carbon changes, and that we're actually able to sequester it in a more recalcitrant form. So that was, from a scientific standpoint, the most surprising thing. Yeah. And I mean, Rebecca knew it, and my student knew it. I just... All right, thank you very much.